Find the magnitude and direction of the electric field at a location 2.88 times 10 to the negative 8th meters from an electron. Step 1, we're going to draw a picture. So I've got an electron. And I want to find the field at a location 2.88 times 10 to the negative 8th meters from here. Now it doesn't say which direction to go, so I'm going to go ahead and just make mine go to the right. 2.88 times 10 to the negative 8th. And that gets me to this point. We want to find the electric field there. Well, it's an electron, so I know that the charge on an electron is negative 1.6 times 10 to the negative 19th coulombs. And I know the distance I am away, because it was given to me as 2.88 times 10 to the negative 8th meters. And I'm trying to find the electric field. We've got two equations for electric field. The first one, the electric field, is equal to Coulomb's constant times the charge divided by the distance you are away squared. And the second one, the electric, In the second one, the electric force is equal to the test charge multiplied by the electric field. Well, this is a test charge. We don't have a test charge. We're just looking at some point out here. So there's no test charge. Also, we are given the charge that's creating the field, and we're given the distance. So we're going to go ahead and use this first equation. So the electric field is equal to Coulomb's constant, 8.99 times 10 to the 9th, multiplied by the charge creating the field, which in this case is an electron, and it has a magnitude of 1.6 times 10 to the negative 19th coulombs. Again, we're not going to put the negative in now. The negative is just going to help us with direction later. And then we're going to divide by the distance squared, 2.88 times 10 to the negative 8th meters squared. And when you square this in the denominator, make sure you do put this in parentheses before you square. And if we go ahead and solve that, we get 1,734,182, and it's approximately just that many newtons. So this is the magnitude. This is how big the force is, the electric field is. It's newtons per coulomb. At a point 2.88 times 10 to the negative 8th meters away, but we were asked to find the magnitude and the direction. So now we need to worry about the direction. Well, the positives and negatives tell us about that. And we learned that when we have an electric field, the electric field lines point away from positive charges and toward negative charges. So electric field lines are going to be pointing towards this charge. So in this case, it's going to be pointing to the left. Now, I got to choose where I put my test point as long as it was 2.88 times 10 to the negative 8th meters away. So instead of writing the specific direction, I'm going to say it is towards the electron.